This video will explain how to use the process flow editor and how to use flow-related statements using the flow settings. First, open the How to Define a Process Modeling Flow.vcmx. We will set a flow to this layout. Go to the Process tab, Editor, and click Flow to display the Process Flow Editor. To set a flow, you need to add some processes to the Process Flow Editor. There are 3 ways to add a process. By clicking a process label on the 3D world, by dragging and dropping a process label on the 3D world onto the flow step, or by clicking the plus icon on the right side of the Process Flow Editor. When a process is selected, it will change from blue to yellow. When this process is yellow, selecting another process will allow you to set a flow. Clicking the process label instead of the process will select all processes with the same name. We will now set a flow in the order of feeder, manual process, parametric lathe, and then sync. By doing this, we have set a flow. Play the simulation. The products will flow in the order of feeder, manual process, parametric lathe, and then sync. This section will explain the operations of the Process Flow Editor. Dragging and moving a process in the Process Flow Editor allows you to change the order of the process. Dragging or deleting a process in the Process Flow Editor will create an empty flow step where the original process was located. If an empty flow step is reached in the process flow when the flow is running, the flow process will be interrupted as the empty step process cannot be identified. Make sure that an empty flow step is not created when setting a flow. In the process flow, multiple processes can be set to a single step. As an example, this explanation will change the name of the parametric lathe and will set a multiple of processes. The name of a process can be changed in the Routine Properties window, which is displayed by right-clicking the process label. Change the name of 2 of the parametric lathes to Parametric Lathe 2 and Parametric Lathe 3 respectively. After doing this, play the simulation. As the processes Parametric Lathe 2 and Parametric Lathe 3 are not part of the process flow, the products will no longer flow to them. Now we will add Parametric Lathe 2 and Parametric Lathe 3 below Parametric Lathe in the Process Flow Editor. Play the simulation again. We can now see products flowing to Parametric Lathe 2 and Parametric Lathe 3. Steps with multiple processes can be moved together by selecting the handle above them on the Process Flow Editor and dragging it. This section will now explain the handle properties. First, we will explain process mode. The process mode setting is used for steps with multiple processes and sets which processes are executed. If set to first available process, availability is checked in the order of the process flow, and the flow will run from the first available process. Here we will change the order on the Process Flow Editor to Parametric Lathe 3, Parametric Lathe 2, Parametric Lathe. Play the simulation. We can see that products flow to the parametric lathes in the order of Parametric Lathe 3, Parametric Lathe 2, and then Parametric Lathe. When there are multiple available processes, the flow runs with the process at the top of the Process Flow Editor prioritized. Select multiple parametric lathe components. Go to the Component Properties window, the Default tab, and change process time to 1. Play the simulation. As either parametric lathe 3 or parametric lathe 2 is always available, products will no longer flow to parametric lathe. If the process mode is set to all processes in any order, the flow runs all the processes within the step. Change process mode to all processes in any order. You will see that the shape of the process label icon on the process flow editor has changed. Here, the flow runs with parametric lathe 3, parametric lathe 2, parametric lathe being used in a random order. We will now change the settings to confirm the operation. Add transport links between all of the parametric lathes so that the products goes through parametric lathe 3, parametric lathe 2, and parametric lathe. There is no need to configure any additional settings for the process flow here. Play the simulation. The products will now pass through the 3 parametric lathes before moving to the sink. Change process mode back to first available process. Delete the transport links that go between the parametric lathes. Select multiple parametric lathe and change their process time back to 60. This concludes the explanation on process mode. This section will now explain about IsOptional. The IsOptional setting is used for running a separate process when the next process in the flow cannot be used. We will use the IsOptional setting to make a product wait at a buffer when moving from manual process to the parametric lathe, but none of the parametric lathes can be used. First, we will modify the layout. Go to the eCatalog window, Models by Type, PM Warehousing, and place a warehouse shelf onto the 3D world. We will now add transport links so that the flow goes in the order of feeder, manual process, buffer, parametric lathe or parametric lathe 2 or parametric lathe 3, and then sink. Do not delete the transport link between the manual process and the parametric lathe. Play the simulation. Products will now flow in the order of feeder, manual process, buffer, parametric lathe or parametric lathe 2 or parametric lathe 3, and then sink. With the current settings, the product will flow to a parametric lathe via the buffer even when the parametric lathe is available. We will now change the settings. Click the buffer handle. In the Properties window, select the IsOptional checkbox to enable it. On the Process Flow Editor, we can see that the border of the buffer icon and the transport link icon between buffer and parametric lathe has changed to yellow, and a transport link icon has been added before the buffer. By doing this, the flow will now switch between processes depending on the status of the processes. Products will now flow in the order of manual process, parametric lathe when any of the parametric lathes are available. Here, processes with a yellow border will be skipped. When any of the parametric lathe are not available, products will flow in the order of manual process, buffer, and then parametric lathe. Products will wait at the buffer until a parametric lathe becomes available. Now, process with a yellow border will run. We leave the transport link between the manual process and parametric lathe in the flow because it will be used if a parametric lathe is available when IsOptional is enabled. Play the simulation. At the beginning, all parametric lathes are available, therefore products will flow from manual process to parametric lathe. When all of the parametric lathes are in use, the product moves to the buffer and waits until a parametric lathe is available. By using the IsOptional setting, we can use the same process with the same name multiple times in the same flow step. We will add a setting so that products flow via the buffer before flowing to the manual process. Add transport links so that the feeder, manual process flow becomes feeder, buffer, manual process. Change the product production method to batch production to easily confirm the operation. Click the feeder process. Go to the Component Properties window, the Product Creator tab, and change feed mode to batch. Change batch interval to 720, product to cube, and count to 25. Play the simulation. The products will flow through the process without error. This concludes the explanation on IsOptional. We will now add a setting to the flow so that the manual process generates a defective product with a certain probability, and defective products will flow directly to the sink without going through the buffer or parametric lathe. One method to do this is to add a defective product dedicated flow group process that can be switched to, however, this will not be used in this explanation. We will use the process flow sequence statements to set switching to within a single flow group. To prepare, click the sink handle. In the Properties window, change the name to Defects in Sink. Next, we will add a setting to the manual process. Go to the Process tab, and with Flow under Editor selected, right-click the process label of the manual process on the left. Then, with State Blocked selected on the pop-up window, add an if statement from statements indicated by the 9 circles icon. Click the added if statement and in the Statement Properties window, set the condition to uniform 0, 0, 100, less than symbol, 10. This is a condition where every time an if statement is executed, a numerical value between 0 and 100 is randomly generated, and if this value is less than 10, the then process runs. If greater than 10, the else process runs. Defective products are generated under the then process, which are then moved directly to the sink. Click Empty under the then process. From the Statements icon, add a Set Node material. This statement will be used as it is as its default setting changes the material of the product in product variable name to red. With this, 10% of products will be defective, and any defective products will be shown in red. Next, we will add a Get Flow step from the Statements icon. This statement saves flow step information to variables. Flow step source sets the obtained information. In this explanation, we will set this to flow step. Return variable name sets the name of the variable that obtained information is saved to. In this explanation, we will use the default flow info. Flow group sets the flow group from which information is obtained. We will set this to flow group number 1. Flow step sets which flow step information from the flow group is obtained with a list box. We will set this to 5 defects in sink. With these settings, sink flow step information from flow group number 1 will be obtained and saved in flow info. Next, we will add a Set Next Flow step from the Statements icon. This statement can rewrite the product and destination information to flow info. For this explanation, we will use the default for each setting. This will generate a defective product with a 10% possibility, and if defective, we'll send it to the sink. Set the remaining manual process. Copy the if statement and paste it under state blocked in the remaining manual process. Select Get Flow Step, and in the Statement Properties window, change Flow Step Source to Product's Current Process. With Get Flow Step selected, add Find Flow Step from the Statements icon. This statement searches for flow steps before and after the current flow step. Change Process Defined to Sync. Processing is now different between the two manual processes, but now both of them generate a red defective product 10% of the time, which when generated is sent directly to the sink. For the final step, we will add a transport link between the manual process and the sink. By doing this, we have added a defective product setting. Play the simulation. We can see that with a defined probability, the manual process generates a defective product, which then flows directly to the sink. This concludes the explanation on how to define a process modeling flow. Thank you for watching.